DeepSeek v3.1, another contender, I guess you could say, stepping into the always crowded arena of artificial intelligence, promising, well, moon on a stick as they tend to do. You all sent in a whole pile of documents on this one, technical specs, breathless reviews, all the usual AI boosterism. So let's sift through the digital dust here, see if there's anything genuinely intriguing beneath the marketing gloss. What do you think? So DeepSeek v3.1 launched, I think it was back in March of 2025. Big launch, lots of fanfare, and the big headline grabbers, the things that they really wanted everybody to know about it, were enhanced logical inference, better handling of just massive, truly epic amounts of information, and a sort of Babel-like embrace of global languages, all the languages. Oh, and the now almost obligatory, open sourcing of a smaller version, presumably to get the developer community, good and buzzed about it. Some folks have even started calling it DeepSeek 0324 or just version 3.1. Just to add to the delightful confusion that always seems to surround these rapidly evolving technologies, right? So let's start with this supposed leap in reasoning. 43% better at multi-step reasoning, they claim, thanks to some novel architectural design. You've heard it all before, haven't you? It's these models are always right on the cusp of truly thinking. But what does it actually mean, right, for you? Are we talking about an AI that can finally understand your tax return, or just one that's marginally better at playing Go? Apparently, this supposed improvement should lead to more accurate answers in areas like mathematics, code generation, and even scientific analysis. So they're building on their previous reasoning optimized model. It was called DeepSeek R1. Remember that one? And the benchmarks, the tests that they run, they do suggest that v3.1 is at least rubbing shoulders now with those big proprietary models in these so-called cognitive tasks.
But this progress in mathematical reasoning, supposedly a direct result of that R1 foundation, seems to be a particular point of pride for them. So what do you think? What kind of complex problems do you think a genuine 43% boost in reasoning could help solve? In your own life, in your own work. I'm genuinely curious. Leave a comment and let me know. Now this novel architectural design that supposedly underpins all this reasoning prowess, naturally they're not giving away, the whole secret sauce, but we can at least piece together some of the ingredients. So it's built on the now, I guess you could say, ubiquitous transformer architecture, but with a rather complex kind of layer cake on top, mixture of experts or MOE. You can think of it like this: instead of one giant brain sort of tackling every problem, the model has a collection of smaller, more specialized brains, experts they call them, and only the most relevant ones are sort of activated for a given task.
So in DeepSeek v3.1, we're talking about a staggering 671 billion parameters in total, but only around 37 billion are active for any single input. It's a clever way to achieve a massive capacity without melting the servers, right? They're also using something called multi-head latent attention or MLA. Multi-head attention itself is already pretty standard. It's a standard technique that allows the model to look at different parts of the input all at the same time. MLA is likely kind of a refinement on that, perhaps making the model even more discerning about what information is truly important. It's all about efficiency, isn't it? And then to further speed things up, they're using FP8 mixed precision during training. It's a technical trick that basically lets them use lower precision numbers to crunch data faster and use less memory in the process. Pretty impressive if it actually delivers, wouldn't you agree?
And then there's the matter of the context window. The amount of information that the model can hold in its working memory, I guess you could call it, at any given time. Now, officially, they're touting a massive 1 million tokens. That's theoretically enough to digest entire books or vast swathes of code in one go. However, if you dig into some of the more technical reports, you'll see that they also mention a 128K token context window, and they achieved this through something called Yarn, yet another RopeNet extension. So, the million token figure sounds, fantastic. It's aspirational. It generates headlines. But the 128K via Yarn, that's probably the more practical reality at the moment. But even 128,000 tokens, that's a significant jump, right, compared to many existing models that are operating in the tens of thousands.
So this larger window regardless of what the final universally available size ends up being, it means that the AI should be much better at maintaining coherence over over long conversations and analyzing really lengthy documents without losing track of the key details. And Yarn itself, it's an extension to the ROP mechanism, row reposition embedding, which is used to to help the transformer architecture understand the order of words in a sequence, and that's especially crucial for these for these longer contexts that we're talking about. It's all about preventing the AI from getting lost in the sheer volume of information, and let's not forget the linguistic ambitions here. They're talking about superior multilingual support. They say it's potentially over 140 languages with near native fluency, and with a particular emphasis on Asian languages and those so-called low resource languages. It's a laudable goal. This breaking down of language barriers.
Whether near native fluency is actually achievable, across such a vast array of languages, that remains to be seen, of course. But if they've genuinely made some strides in supporting languages that haven't traditionally been well represented in AI training data, well, that's a positive development. It could certainly lead to some really interesting applications in global communication and accessibility, wouldn't you say? Now, a really crucial metric for any AI that wants to achieve real world usefulness, the dreaded hallucinations, those moments when the model just confidently spouts utter nonsense. DeepSeek v3.1 they say it shows a 38% reduction in these fabrications compared to its predecessor. So that's a significant improvement, at least on paper. Whether it translates to a truly trustworthy AI, that's another question entirely. I mean, 38% fewer hallucinations still leaves room for for hallucinations, right?
So it's a step in the right direction, perhaps, but this fundamental issue of grounding these language models in verifiable fact, it remains a challenge, doesn't it? And of course, no self-respecting AI launch is complete without a whole battery of benchmarks, right? NMLU at 88.5%, Human Evil More at 82.6%, Live Code Bench at 40.5%. I mean, these numbers they're often thrown around with such an air of scientific authority, aren't they? But on MLU, which supposedly tests general language understanding, DeepSeek v3 actually it nudges ahead of GPT-4o, and in coding on Human Eval More and Live Code Bench, it seems to outperform Claude 3.7 Sonnet and GPT-4o in at least certain tests. It even boasts a Codeforces rating of 1691. I mean, that suggests some pretty serious competitive programming chops, right? However, on SW Bench Verified, which focuses on more complex software engineering tasks, it falls behind.
And while it did outperform some models like Gemini and Copilot in certain coding tests, at least according to one review, it only matched the older GPT 3.5 and others. It's a reminder that these benchmarks, these tests, they're just snapshots. They're testing specific skills under very controlled conditions. The real world performance, that can be a far more nuanced affair. It is interesting to note, however, that the training of DeepSeek v3 was apparently quite efficient. It required fewer GPU hours than its earlier iterations to achieve a comparable level of performance. They even managed to improve on that slightly with v3.1. So efficiency in this in this computationally intensive field, that's certainly something to keep an eye on. So peering under the hood a bit more, the architecture involves this mixture of expert setup, the one that we talked about earlier,
with those hundreds of billions of parameters, but only a fraction of them actually active at any given time. They're also using this multi-head latent attention for supposedly more efficient information processing. The training process itself involved a massive data set. I mean, we're talking about 14.8 trillion tokens. I mean, a truly mind-boggling figure, encompassing academic papers, code, books in over 140 languages, and all the other digital detritus that these models seem to feast upon. They use a combination of pre-training, supervised fine-tuning, and reinforcement learning, the standard toolkit really. But they also apparently employed a novel method to distill reasoning abilities from their earlier DeepSeek R1 model into this new V3, and the use of FP8 mixed precision throughout the training process is another key factor in achieving that efficiency that we were talking about. They've even developed something called dual pipe.
And that's to speed up the pipeline parallelism that's needed for these massive MoE models. It's a complex engineering puzzle, to be sure. So the so-called expert opinions on DeepSeek v3.1, they are as always a mixed bag of cautious optimism and outright hyperbole. It's being touted as a top non-reasoning model, whatever that precisely entails. They say it's comparable to Claude 3.7 Sonic. Some users have reported positive experiences, especially in creative coding. The very fact that people have started using the term DeepSeek moment, that suggests that their previous work has indeed made some waves. It's even being floated as a promising tool in education. And while some still see Claude 3.7 as the king of coding, DeepSeek is clearly in the running. Some reviews suggest it's excellent for coding, for brainstorming, for creative writing, potentially rivaling OpenAI's O1, but at a lower cost.
However, those persistent whispers of hallucination issues, making it unsuitable for truly formal reports, those remain, and concerns have been raised about potential vulnerabilities to prompt attacks and even privacy implications. It's the familiar story, isn't it? Impressive capabilities tempered by ongoing limitations and potential pitfalls. So what does all this mean for you? Well, the potential applications that people are talking about are pretty wide-ranging. More sophisticated software development tools, faster scientific research, more personalized learning experiences, multilingual content creation, smarter business intelligence, all the usual suspects. People are already talking about using it to build AI blogs for passive income, create SEO tools, generate synthetic data, automate those tedious literature reviews, simplify overly complex technical jargon, and even prototype new research tools.
Whether these promises will fully materialize, remain to be seen. Ultimately, DeepSeek v3.1 appears to be another significant step in this relentless march of AI development. It boasts some genuinely impressive technical achievements, particularly in its architecture and its reported efficiency. The benchmarks suggest it's a strong contender in several key areas, though not universally dominant. And while the claims of reduced hallucinations are encouraging, the fundamental limitations of these models, they do persist. It's a fascinating, if occasionally bewildering, landscape, isn't it? So what are your overall impressions of this latest AI offering? Does it pique your interest, or is it just another iteration in a seemingly endless cycle of incremental improvements? Let me know your thoughts. Thank you very much for listening. Leave a like and subscribe. Until next time.